Introduction to kinetic and potential energy. Kinetic and potential energy are two fundamental concepts in physics, representing different forms of energy that an object can have based on its motion or position. Both are crucial for understanding energy transfer and transformation in physical systems. What is kinetic energy? Kinetic energy is the energy possessed by an object due to its motion. The amount of kinetic energy an object has depends on its mass and velocity. The faster an object moves, the more kinetic energy it possesses, and the larger its mass, the greater its kinetic energy. Formula for kinetic energy. The formula for kinetic energy is K equals 1/2 mv squared, where m represents mass and v represents velocity. This equation shows that kinetic energy increases with the square of the velocity, meaning even small increases in speed result in significant energy changes. What is potential energy? Potential energy is the energy stored in an object due to its position or state. It can be gravitational, elastic, or chemical energy, depending on the forces acting on the object. For instance, an object held at a height has gravitational potential energy because of Earth's gravitational pull. Formula for potential energy. Gravitational potential energy is calculated using the formula P equals mgh, where m is mass, g is the acceleration due to gravity, and h is the height. This energy is stored and can be converted into kinetic energy when the object moves, like when a ball falls. Key differences between kinetic and potential energy. Kinetic energy is associated with motion, while potential energy is associated with position or configuration. Kinetic energy depends on velocity and mass, whereas potential energy depends on factors like height, force, and the state of the object. Relationship between kinetic and potential energy. Kinetic and potential energy are often interchangeable. In a system like a pendulum, the potential energy at the highest point converts to kinetic energy as it moves downward. This transformation between the two forms of energy is a fundamental principle of mechanics. Conservation of mechanical energy. In an isolated system, the total mechanical energy, kinetic plus potential energy, remains constant, assuming no friction or external forces. This is known as the law of conservation of energy, meaning that energy is conserved as it transforms from one type to another. Examples of kinetic and potential energy. A car moving down a road has kinetic energy, while a roller coaster at the top of a hill has potential energy. As the roller coaster descends, its potential energy is converted to kinetic energy, which accelerates it down the track. Conclusion. Understanding energy types. The key difference between kinetic and potential energy lies in motion and position. Kinetic energy is the energy of movement, while potential energy is stored energy due to position. Both are integral to understanding how energy behaves and is conserved in physical systems.